All right, it's 7:30 and we're going to get started. All right, thank you. Okay, so before we get going here, our opening slide has a very nice picture from Stan of a new supernova in NGC 7331. Stan, did you want to tell us anything about your picture?
Well, I zoomed in a lot because I have a lot of fires going on and stuff like that, you know. So I zoomed in a lot and fly so fuzzy and then processed it and zoomed in image. The supernova was first found by one of these robot telescope systems that they've got out there. I think it's in community. And it was first found July 15th.
Excellent.
I heard that and I picked it there on the internet a couple of weeks ago.
Excellent.
Still going. If I were to do it again, I'd probably short exposure for like 60 seconds and take more of them. I think the core would not be so boring. I didn't use a pollution filter like a chili. I only use it ultra high contrast, which removes a lot of pollution. There's a lot of processing to get the pollution out of there, and that's another reason why it's so fuzzy and the stars are so green.
Okay, great. Well, thanks for
total of 60 exposure, 60 exposure.
Yes.
that's on the low end.
Oh, yeah.
All right. Well, thanks for contributing that. Great. Okay, here's our agenda for this evening. But before we get started, we'd like to find if there's anyone who's your first time here. Raise your hand, tell us your name, how you found out about the JSC Astronomical Society, and what your interest is in astronomy. You're not really new. You just haven't been here for 100 years.
I'm Randy. I was a pretty active member back in the 90s. And I also retired and moved to the northwest side of town 2 years ago. So it's a long drive, but I have joined on the internet and on the list server.
Oh my goodness.
But I was a club secretary for a while.
I believe it.
I'm mostly been out just make it out. I moved to the northwest side of town thinking I was going to get some good skies as I was away from Houston, but it's worse actually. Car dealerships and all sorts of factories. But my daughter's up there, and my other daughter lives up in Fort Worth, so closer to family.
Excellent. Anybody else?
And I didn't have one thing about Randy.
They used to work together in the Air Force here many years ago.
Oh my
We were in the
goodness.
same office.
4 years ago, July 27th, we met.
I think so, something like that.
My first day at work, he was my captain,
Mhm.
the training
Right,
secretary.
so.
Great. Well, we're glad you're back. Okay, anybody else? First time here? Okay, nobody else wants to admit it's their first time here. That's fine with me. Okay, so we have two email distributions. One of them is for members only. And last month, a members only notice came out, but one did not come out this month. So if you want to take your chances on members only, you can send an email to this and get added. But if you want to be sure to get all of our emails, you can send one to David at this email address. And if you don't have time to get those down, Al, thank you, Al, is holding up our clipboard and has some little tear off tabs, and you can tear off those email addresses and get added to our distribution. Reminder to presenters. Okay, so the mouse pointer is built into the computer here. So please use this mouse that's built on the computer so the online audience can see what you're pointing at. We have a larger online audience than we have in person.
And so the online audience, I guess, only sees the presentation, they'll have to look at me, so.
That's what they see right there. Yeah. So Charles, please just use this pointer. And then the other thing you need to know is the microphone for the stream is in this laptop. And then the auditorium mic is right here. So you can't really move around too much. You got to pretty much stay pretty much here for the people online to hear what you're talking about. So yeah, all speakers. I'm glad you guys are paying attention this time. All right. So that's two things you need to know. Oh, okay. So time for our main presentation. Charles is going to tell us about tracking satellites, why and how. But first, before Charles comes up here, let me tell you a little bit about him. Actually, I know Charles because our kids used to go to school at the same school, and he has triplets.
Exactly, right.
So he was like an anomaly, and it was kind of cool. He had 3 boys, and I had 2 boys. And anyway, all right. So Charles Phillips has a BS in physics and an MS in space operations as a retired United States Air Force lieutenant colonel who started his career in 1978 working as an orbital analyst in the Space Computational Center in the Cheyenne Mountain Complex in Colorado. From there, he went to be a senior director at Clear Air Force Station in Alaska at the Ballistic Missile Early Warning System radar site. As an active duty Air Force officer, he was a space shuttle flight controller and was stationed at the Johnson Space Center during the STS-51-C, 51-J, and 51-L, STS-26 and 27 missions. Then he was a flight controller for Space Lab Life Sciences STS-40 and supported Space Lab Life Sciences STS-58. Since then, he has worked on the Shuttle Mir program, the ISS Human Research Facility, and did space shuttle and ISS safety. Now he's an independent orbital analyst, astronomer, and satellite tracker. So join me in welcoming Charles Phillips. Oh. So Charles, to get to go forward, you just hit
Just
enter.
Oh, okay.
Enter.
Yeah.
Yeah.
Well, great. I've had quite a a career with I've done a lot of various things, and it's sort of funny that here, sort of late in life, I've kind of come back to where I started when I started off doing orbital analysis. The U.S. government was the Air Force time, now the Space Force. They're sort of like we'll talk about it in a couple seconds. They're one of the main groups in the world who track satellites, and I have kind of come back to that. But it was something I was very interested in at the time. I did bring my setup, and I'll probably talk about that in a couple of seconds after this. I just wanted to let y'all know how or what kind of equipment and very inexpensive and easily available equipment I use. Okay. So this small thing, and I think it's a pack of cigarettes, is a part of a U.S. Centaur upper stage. So you, as I said, the U.S. government and many companies these days track satellites like ISS, like Hubble Space Telescope, lots of satellites, geosynchronous satellites, things like that. There's a lot of companies track geosynchronous satellites, for instance, that's the ones which people pay money for. You know, they want to know where they are and how close they are and how close they can get them. So I'm actually part of an international group. A lot of the people are in South Africa. This guy Greg, Kay's Bassas in Sweden, stuff like that. International group, and the genesis of that group, very interesting. Back way a long time ago, when the Russians first launched Sputnik, the U.S. government and several other governments sponsored Operation Moonwatch, where they encouraged people to track satellites with very, very primitive equipment, of course, like stone knives with bear skin. So anyway, and there's still a tiny little bit of that group left. So you might want to know, why do we track satellites? If you look at ISS, there's lots of people tracking it. So why do you track satellites? So I figure this group probably knows a bit more about the subject. So I'm not gonna avoid. I do talk about this sometimes with non-technical groups and avoid technical talk. I'm going to zoom on in there. Many satellites at the end of life, they maybe they have engines and things like that. They will re-enter and they hit the ground. So the U.S. Space Force, currently based in Vandenberg, California, they are the world authority. Better do that again. To say, when do satellites hit the ground? And it's like, warn people, look out. A lot of these things are very large, like a Centaur upper stage, fairly large. So if the U.S. government knows a satellite has a good chance of hitting the ground, it should alert the public. Okay. And for instance, November 3rd, 2015, I'm not going to read this chart. I always say I never do that. A satellite did re-enter in Spain. And people said, well, what is this? And also some people said, why were we not warned? And there's not like a law you must, but why not? You know what I mean? And they actually picked up the pieces that scattered fairly near Madrid, and they got the pieces and they turned it to be parts of a Centaur upper stage. We launched Centaur, it's U.S. upper stage. And this is where you could probably get the presentation and go to this site. The satobs.org is this group of people called the Visual Satellite Observers. We're people who observe and track satellites. And this is a big story about they got it and how they decided what the satellite was and all that. Okay, so they checked the standard re-entry warning pages and it wasn't there. So what? And as you can see, these are a composite wrapped fuel tank, fairly large pieces actually could injure somebody if they hit them. This same thing also happened, but 2 years ago, 2 years later, I think, and another different kind of upper stage hit in Mongolia, and we got pieces back from that as well. So that was one of the first things I ever did when I was in the Air Force as an orbital analyst. I started orbital analysis in November 1978. In 1979, the Skylab re-entered and hit Australia. And I was just really fascinated. I've worked that whole thing and was just fascinated by re-entries. It just kind of stuck with me. So anyway, part of the motivation for these people tracking satellites is we try to predict the re-entries, not like really to warn people or anything like that, but at least what's going on. So let's talk briefly about the satellite catalog. Okay, now this is a web page, of course, these days. And the U.S. Space Force maintains it, and it's I think I put spacetrack.org. You can see the URL there. You can go and you can look at every satellite that we know about, even many of them that like landed on the moon. They have satellites, like on Mars, things like that. But of course, it's mainly designed for people who track satellites to see like collision warnings. We've had several collisions and things like that. And all that. So the satellite catalog is a big web page, and it gives you each satellite oddly has 3 designations of satellite number. It has an international designator, which says what year it launched and the year, stuff like, and it has a name. But anyway, so there are many of the satellites, like the Centaur upper stage that hit the ground in Spain, which are showing up here. I'm not going to walk over there. You can see that there are numbers like perigee, apogee, period, inclination, INCL inclination. So here's a bunch of satellites. Here's USA 144, right? Binoculars. USA 144. It doesn't have an inclination for it, Now, oddly, here's the upper stage, Titan 4 upper stage, which does show things like period, inclination, apogee, perigee, stuff like that. So we started out by not putting in the orbital parameters in the satellite catalog. You can go and see the inclination, stuff like that, eccentricity, things like that of satellites. But for US Intel satellites, we started to not put in information because we thought, the Soviets could track them. So we don't want to give the Soviets the orbital parameters of our like KH-11s and KH-8s and 9s, photosatellites, ELINT, SIGINT, stuff like that. So they would just leave it blank. But if you look at the satellite catalog kind of carefully, and that was the first job I ever did, was maintain the satellite catalog before, of course, web pages ever came around. But it's been inconsistently applied, and you can see some satellites where parts are shown in there, and you could sort of find a payload if you knew where the upper stage of rocket body was. Anyway, so we sort of got our group got sort of infamous in some ways, perhaps, for tracking satellites which the U.S. government, when they were the only ones handing out orbital parameters, would not give you the orbital parameters of those satellites. Now, especially once you like the launch zones are publicly released, so you don't hit boats and things. So there's stuff like that. So it's fairly easy for most of these satellites to calculate an orbit and find them anyway. So and today, of course, with like lots of satellite trackers out there, it's really overcome by events that we should simply hand out all these orbital parameters. It's kind of silly to keep them out. But also, we have agreements with other countries like Israel, Italy, if they launch like ELINT or stuff like that satellites, we actually leave those blank in the satellite catalog as well. So anyway, so there's an international group of astronomers, and I'm one of them. And there's our webpage there. And we track these off-the-book satellites because it's fun. It's interesting to like calculate the orbital parameters and figure out what they're doing and stuff like that. So just briefly, this is my whole setup here. It's fortunately a very inexpensive hobby. I have a used Nikon camera. I hooked it up to the laptop, and I'll talk about that in a couple of seconds here. The one thing I'm not going to walk over to is the little thing hanging from the camera is the key that I had. I actually had a friend of mine who lives in Austin build me a timer that gives me very, very, very accurate time. I talk about time for an hour, but don't bother you with that, So there's a bunch of people around the world, and we take photographs, satellites. Most people use those ZWO. Most people use video cameras. I'm I think the only person, one of the few people using a DSLR. So we get photographs, and I'll show you in a couple of seconds where I do astrometry to get the RA and DEC, in time, very, very, very exact time. And we all email our observations. We call observations. This guy, Mike McCants, in Austin. He happens to be the center of the universe at the moment. He's like 85 or something like that. I don't know. So he may retire at some point, So a lot of people in our group, we track, I track mainly near Earth satellites. We'll talk about that just due to the seeing is so bad around here. I have to have a fairly bright satellite to be able to get a photograph of it. I've gotten photographs of geosynchronous satellites and stuff like that. Those are more challenging to get around here. So normally I track like a lot of there's a very bright near Earth satellites. Like, does anybody have ever heard of the Future Imagery Architecture? It was a Boeing program for a while to develop new imaging satellites. They're so bright you can see them even in my old eyes, in the winter, Anyway, so we track a lot of the near Earth satellites. Like, anybody heard of the NOS or White Cloud, or also called Parquet? It's a Navy program from years ago that did radio interferometry of ships at sea and all that. So we track those and some deep space satellites. And like the one guy, Ted Molkson, down here, bottom of the chart here. Ted Molkson's a Canadian guy. Kees Bassa is in Netherlands. He's actually a professional astronomer. Greg Roberts, stuff like that. And so we kind of exchange notes and stuff like that, all by email, of course, and everybody sends their observations to Mike McCants in Austin, who generates the orbital parameters. So he is like unique, so he does parameters which are, it's consistent, probably those who put it. Now, due to the poor seeing we have here, I really do a lot more analytical astronomy right now. So I get orbital parameters. And have you heard of the term, the three-line element set or two-line element set, TLE? So normally Mike McCants puts out a list of TLEs for a whole series of satellites. And what I normally do is I get those, and getting the TLEs or orbital parameters, I can see how they change over time. So I've actually written a number of articles. Everybody has heard of a site called The Space Review. There's a guy named Jeff Faust who works for a Space News, has a site, and people can submit articles. I think I'm probably the one that submitted the most articles, and a lot of the stuff that I do is based on my orbital analysis experience from before. I am actually, I can't believe I'm doing this. I'm actually developing a new technique. So if you have a spacecraft up there or any kind of an object, you can take an unknown, because there are many, many unknown objects up there in space, and you can actually track back to what launch it came up on. And that is kind of useful because if like a piece of debris hits like an orbital or like a payload, you can have blame. I don't know what it would do, but at least you'd know who did it, So every object up there in space that would like to have the idea of who owns it. Is it India? Is it Indonesia? Oddly, there is no Russia in the space catalog, the satellite catalog. It's the Commonwealth of Independent States, what the Russia was for a short while. But anyway. Oh well.
Okay.
And then we'll have a fire alarm. So okay, it's not. There's no fire. It's not burning. It's a very small fire. Anyway, and I have somewhat talked to the people who actually run the satellite catalog. You can occasionally get them to answer email, and I've sort of encouraged them to a lot of these spacecraft, like a lot of the very old spacecraft, they've never released the orbital parameters for them, but a lot of them are satellites which retired years ago. So it's silly for them to not release the parameters, and it's also potentially silly if one of those things ever entered the atmosphere and hit somebody. I hope that the U.S. government would say sorry. You know what I mean? But anyway, so it's a sort of an odd hobby, but it's actually a lot of fun. I've actually had to write several little pieces of software to do some of this analysis stuff, and it's been very interesting teaching myself how to do that. And as I said, I'm actually working on an academic paper, which I've actually talked to the AIAA astrodynamics people about. They're actually doing their every year conference that starts like today, which I didn't make it for this one, but anyway, maybe next year, So one of the things that we do is we predict decays. Now, for various reasons, a lot of the satellites, which are off the book satellites, does anybody know that, like, have heard of the, like, the Molniya series of was Soviet, now Russian spacecraft, high eccentricity, yeah, like the Molniyas, and the U.S. has used those orbits a lot for, like, a lot of ELINTs and SIGINTs, like jump seat and things like that, you know, not Mentors, geosynchronous, stuff like that. And it's odd that when I was at the Cheyenne Mountain Complex years ago, I supported a lot of these programs in the early days. You know, actually, I supported the NOS program. I had the clearances and things like that. You know, actually, I've talked to them on the phone. It's been quite a long time, you know. But anyway, so I've been trying to get better at predicting reentries for some of these things. Now, most of these high eccentricity satellites, for various reasons, they're used for communications or for surveillance of like the northern hemisphere. You know, like in the southern hemisphere, there's nothing down there but water, basically. You know, and a lot of contentious conflicts about Russia and China and, you know, United States and stuff like that. So a lot of the those high eccentricity satellites have a perigee over the southern hemisphere and an apogee over the northern hemisphere. You know, and we can talk about orbital analysis all day long. And so most of these spacecraft, when they die, will actually re-enter where? In the southern hemisphere. You see that the red stuff on the to the west of South America. That was one prediction I did. Well, it wasn't a prediction. After the satellite had re-entered, means whether buddies determined the actual point. But so most of these satellites will re-enter, fortunately, in the southern hemisphere like this because of inclination. But you know, I don't want to go into that too much here, even with this group. But many of the inclinations of these satellites are like 21 degrees or so. They're launched out of the Cape Canaveral, and they're like geosynchronous transfer orbits and stuff like this. And so that was the one that re-entered in Spain. So a lot of these with lower inclinations will re-enter in equatorial areas and might hit somebody one of these days, you know. Anyway, so I mentioned Greg Roberts there in South Africa. He helped a lot of historical stuff. He actually was a South African astronomer, and actually was, as a young man, was in Operation Moonwatch. Anyway, so like I say, like this one here. So most of these kind of problematical spacecraft or their upper stages will re-enter in the southern hemisphere. But I'm more interested. There's one Japanese upper stage right now, which is a inclination of about 21 or 22 degrees, and the perigee is getting kind of low now. But it delivered a Japanese, like an ELINT or whatever satellite to geosynchronous orbit years ago, and so it's getting fairly low, but it doesn't show up in the satellite catalog. They were not going to predict the reentry anyway. So okay, Chuck. You know, so how do you do this? What kind of stuff do you use? And you will laugh when I show you kind of the cheesy little thing I have. So I have a used Nikon camera. I wanted a really good solid camera with good optics, 50 millimeter lens. This is like, you know, you could go to Houston Camera Exchange. They'll almost give those things to you. You know, who needs a 50 millimeter? I have a 85 millimeter lens that didn't bring today. But anyway, and then my laptop. And the key is this thing this guy, John Dormer, built for me, the timer. So the satellites I'm looking at travel 17,500 miles an hour, I think it is, about that. So low orbit satellites, under 1,000 kilometers. So I could go into like setting the camera on the clock. The camera on the has a very accurate clock, amazingly, but it's not really designed to get the kind of precision that I need. So I got John to build me this little thing. So the timer, when I hit the shutter, it gives me the exact GPS time that the shutter opens, and then the duration of I usually take a 5 second these days, 5 second exposure. So it gives me gives me 4.904 seconds or whatever. So I need that kind of precision. And I will show you, well, not right. Deploying my camera, you're saying, okay, because I think you all have like these fairly sophisticated telescopes to point to the, Fomalhaut, or stars like Antares or whatever. Well, I actually have a little app on my telephone written by a guy named Tim De Benedictis that shows the arc of the satellite as it goes by. I live just in Brookwood here, and I actually hold up against the back of my camera and then just twist the camera until it's a green green line. And then I start taking pictures a couple of minutes early. Of course, with digital photography, you can take 100 pictures, you never run out of film, So the heart of the system is that timer hanging there. 50 millimeter lens works for me, and so sort of the problems that I have, and I do have, is I get images on the camera, and then this gives me the exact time. Eventually I'll show you later on how it works, of the exposure. And so I have to match those up. And sometimes, it's not plugged in right or whatever. And I take a picture and it doesn't give me the exact time on the, so I have a text file on the computer of the exact time of the exposure, and then I have to match that up very carefully, because if I get the wrong line connected to the wrong photo, just a minute is a huge difference, so that it's not usable. So I have to be very, very careful about that. So the timer gives me a text file on the computer. Right. So it gives me latitude, longitude, time of the shutter, and then the shutter duration. That would be the ideal thing. I've actually gotten a software development kit for the camera to see if I could maybe figure a way to have every photo exported when I take it, but I haven't got to that point yet. That would be, so I could very carefully match up the photo and the time. Anyway, so I think, and everybody out there is probably saying, if you're standing out there in the driveway or, on the road in front of your house, whatever it is, you can't see anything, which normally you can't, right? I mean, I've gotten lots of pictures of clouds. The best thing is on the backside of a cold front, get nice clear air. It's nice and still, stuff like that. But I mean, you don't have cold front too often. Even in the summertime, I can track a lot of these satellites I track are fairly bright, and I can track those. So what I do is I get my camera set up and point it at where the satellite is going to be, and then a couple of seconds before it starts coming through, I'll start to take a picture of a 2-second delay. I only take monochrome photographs, so 2-second delay, and then I've been using 5-second exposures. I've done 10 seconds, 15 seconds. There's different reasons of doing things. So then I get a bunch of photographs, which I take. I'm a Mac guy, so I put all the photographs on my Mac Mini, and then I'll show you a couple seconds here. So the ones which have the satellite in them, I ship off to astrometry.net, okay, which is an online site which gives you, I'm sure everyone knows what astrometry is. So for every star, you get exactly the RA and the deck for it, So anyway, so I get the photographs, ship them off. They come back as a FITS file. FITS is the type of file. I open it up in Smithsonian Astrophysical Observatory has a big piece of software that you can download, and I've torn my hair out many times going through. I could, this is a sort of a activity for somebody who is really neurotic, I guess, or OCD or something. I could tell you about trying to get the software and get it installed in the computer, all the problems. And anyway, so anyway, so I get all this, go through all this stuff. I get type up in Word a file with RA, deck, time, and the satellite that I think it is, and ship it off to Mike McCants. And he runs it through his software and combines it with satellite observations of other people, and then produces these TLEs, and then puts them out in a zip file. And so here's the kind of the there's so that red spot is not. I am going to separate for 1 second. So I'm sure everybody could see that, so that is the result of photography. And then after I resolve the photograph with astrometry.net, I can get the RA and deck of both ends of the streak. And then I get the time from that timer. And that allows me to produce observations. And, fortunately, Mike says I can, after many mistakes, and a lot of effort, Mike says I do very good very accurate observations. There's another one. So and so this is what I get, and you spend a lot of time looking. I usually have to wait till after the sun goes down, of course. Get a nice dark room and all that. And that's it. So I think in the future we'll continue to kind of track these satellites. I could go into another big thing. The U.S. government and other governments has occasionally, released some of these orbital parameters for spacecraft. They declassified them, reclassified them. They go back and forth, but not lately. But I think that over the next 10 years, I plan to keep doing this. It's interesting to do this kind of it's a real challenge, a real intellectual challenge. And it's kind of good to we do take photographs of these various satellites, and then by looking at orbital parameters, you can sort of get maybe what the mission is or something like that. Or it's just a lot of people. I guess it's just maybe kind of fun to get pictures of stuff like that that maybe they they're not going to encourage you to do. So I don't know. So any kind of questions at all, or
these different satellites in your photograph?
Probably like 30 or so. There's some that I sort of concentrate on, but there's other ones that I have I've done for just to see if I could do it. So my actual goal when I started this, what I'd like to try to do is photograph some of these high eccentricity satellites, like in the Molniya type orbits. But those are obviously dim, stuff like that and stuff like that. So, but I've probably gotten 30 or some. A lot of future imagery architecture satellites. There's like about 6 or 8 of those, I think it is. And then a bunch of NOS, Naval Ocean Surveillance System. White Cloud, a bunch of those, and then some other cats and dogs. So I've been trying to get. So Israel has a bunch of satellites. So I've tried. I don't know if I've actually gotten one of those. But I've got a couple of. Let's see, Japan has a couple. I got a couple of Japanese satellites. So okay.
So,
so I can get an observation. It's a line of numbers from each end. Yeah. So it actually is better for me to take shorter exposures, like 5-second exposures, because very often I can get, as the satellite goes. Normally, I get photographs of these satellites when they're to the east. Sometimes to the north and sometimes to the south. I have gotten one. I almost put it in here. I'm very proud of this one. The Hubble Space Telescope was going right by Venus several months ago, which of course, obviously setting to the west, and satellites that are to the west of us are backlit and nearly impossible to get photographs of. But actually, I got Hubble Space Telescope in the image with Venus. As you know, like you know, but yeah. So normally the satellites are to the east, and if you get a place you can see, you can maybe it's going from like northeast to southeast. You can track it with the camera a little bit, move the camera. I've gotten sometimes 4 or maybe even very occasionally 5 photographs of the same satellite in a single pass. And they're usually about how these the takes about 95 minutes or so. So sometimes if the lighting is okay earlier, I could actually get a satellite on 2 separate orbits on the same night. Very, very rare, but sometimes. Okay, here, let's go to the back there. Oh yes, all those web pages like Celestrak, Heavens Above, N2YO, they all get all their information from spacetrack.org. So in the satellite catalog business, that's the U.S. Space Force. That's their web page. In fact, Randy, if you remember Wayne Lewis, for a while, Wayne Lewis was the guy in charge of the people who did that web page. The friend, another guy we knew. Anyway. Well, that's why if I can figure out how to get back. So if you look at Spacetrack, you'll go on, and their satellite number 5 is the lowest satellite that's still up there, or ISS and Space Telescope. You'll see all the parameters. Oh yeah. Oh yeah. Oh yeah. Yeah. And lots of the images that I get these days have 2 or 3 satellites in them, which is kind of a pain. But so all those so Spacetrack is the sort of world's default satellite catalog, and everybody gets their parameters from that. There are other parameters that another group that I've worked with, not a whole lot, but for quite a while, is ISON. So in the good old days, the Soviets and then the Russians have their own satellite catalog. And they don't have the satellite catalog that puts everything online like we do, but they have the International Scientific Optical Network. I think is ISON. And this guy Igor Molotov is the guy that I talked to over there. So they have an online catalog as well. But they only the word uses period, a number of minutes per orbit. See, they only put things on their catalog that have a period or orbital duration of 225 minutes or greater. But you can go and download their whole satellite catalog as well. Because they concentrate like on geosynchronous stuff and stuff like that. So there's still a lot of it's Cold War. A lot of stuff's all based on the Cold War. You know what I mean? And that's why we don't give out the parameters for Israeli, photo satellites, or there's Japanese ELINT satellites, stuff like that. So, and the Russians, they do give out the orbital parameters for like Molniya satellites because they're higher, but they have their low orbit satellites as well. So they don't give out satellites or parameters or anything that's fairly near like ISS. No way, So.
Do you know how many photos does it take that are needed?
That is so to get any kind of the mathematics works out to get an actual complete orbit. That orbit consists of 6 numbers. And time, you actually need 3 points. So each one of my streaks gives you 2 points. So if I get it twice, that's 4. But so that's over only a very small percentage of the orbit. So the accuracy of like the eccentricity or inclination is fairly low. So what you need to be able to do is track an object over a large portion of the orbit, like several times within like maybe a 3 or 4 hour period or over a couple of days, stuff like that, So And it sort of depends, by these low Earth orbit satellites. If you get, if I got like a couple images, twice in one night, that would define the orbit pretty darn accurately. But a lot of stuff that's higher inclination, stuff like that, not so. But then geosynchronous satellites, like or geostationary, going to hang. So it's really only a few observations of those, and you get a fairly accurate orbit. Okay.
Let's pretend that something happened to one of the satellites, and maybe somebody accidentally shot something up there. And
Oh yeah, right.
with the antenna.
Yeah, like pieces or whatever. Oh yeah.
Have any idea where that might actually be?
When I was in the Air Force, it actually worked. I was not there. I arrived shortly after the Soviets concluded their anti-satellite tests and stuff like that. But since then, India's done one, China done one, stuff like that. Yeah, I think if you were to get a photograph like this, you would see multiple streaks all parallel to each other, from the different objects. So that would be able to tell this, pre or is it post collision, and then from each one of those you can get an orbit. So yeah. So
have you ever dealt with changes in the 60 space of these satellites when there was, for instance, a solar storm, there was an increasing atmospheric drag in the atmosphere?
no, that's especially for low Earth orbit type stuff. That's very, very slow stuff. Like Skylab, the first when I was at the China Mountain Complex and predicting reentries for space stuff like Skylab, that very slow. That was a very big solar, like the solar maximum. So the atmosphere expanded and things like that, and the drag increased a lot. But still, it's a fairly slow process. So. Okay.
I can't help but wonder. We started talking about discussing the satellite that.
Oh, right.
If a satellite, what am I supposed to do? Board Windows, plans.
Yeah, that's right. Probably prayer. Well, I do every week or so check the satellite reentries, and we've had like the Chinese have this long march, like the first stage goes in orbit, and it's up for like a week or so, a week and a half, and then reenters. Fortunately, the world is mainly covered by water, and then of course deserts and the Arctic and the stuff like that there. You know what I mean? So your chance of being hit is not very good. Now I think there's a demonstrate or a one instance where a woman was actually hit by a piece of re-entering debris, but it's like fairly light metal. It didn't actually kill her, But they actually have had debris which like punch holes in people's houses and stuff like that, Well, the especially the prediction ahead of time is not very accurate, So not like you can like go inside when it goes overhead or anything like that. It's just a crapshoot. You know what I mean? And nobody's been killed yet. And
Hopefully the government's just made aware that, hey, if something explodes in the city,
right.
maybe
That's what it mainly is. Like if something bad happens, you can go back and figure out what happened. Not like you can warn. So because the accuracy of a prediction is fairly low. So okay. Oh, it's a huge huge variety there, like geosynchronous satellites and stuff like that, and they have quite a few cislunar satellites now. They'll never ever, not in millions of years, will never hit another planet. Like ISS been up there for like a long time, but like we launched like a CubeSat is fairly small, fairly light. Some of those like deployed from ISS, you know, I mean, those will be up there for like 30 days or so, but oh no, not satellite, not the first one. The earliest satellite, interesting, is a U.S. satellite, is satellite number 5. You know, U.S. one of our early satellites, which is still up there. But no, the Sputnik is not up there right now. So I don't know, because at the time, of course, you know, they didn't really have radar coverage and things like that. So they probably have some, yeah. So yeah. But you know, nowadays, of course, the U.S. has a very large radar tracking network that spans the entire world, and so does the Russians have one, and Europe has a fairly expansive satellite tracking network, and things like that. You know, so but, you know, in fact, I actually, when I was at the Cheyenne Mountain Complex, the guy J. Allen Hynek, anybody know who that guy was? Used to be a famous sort of a you know, wondering about UFOs and stuff like that. He actually had a speech in Denver, and I went up to talk to him. You know, heard it after this question answered. I asked him, you know, if anybody had ever tracked a UFO as it went through, because I knew that, you know, with the Air Force at the time, now Space Force radar trackers, it's very hard to hide anything. You know, they say that they could track anything like a basketball or bigger. We track stuff a lot smaller than that if it's close to Earth, you know. So it's very hard to hide anything that like a person or a creature get into, you know. Okay.
What one bird will re-enter this atmosphere in your report 1950?
Yeah. So yeah. Yeah, 58. Yeah. And of course that was an estimate because they didn't have radar trackers at the time. They couldn't we do predictions of re-entering spacecraft today. You know, they couldn't do that at the time. So
Where's all the Starlink satellites?
oh well, I tried to pick some of the satellites. I tried to look. You know, I frequently get, you know, 2, 3, you know, maybe 4 satellites in the frame at a time. But I picked these here. This one, and if I know how to back up, backspace. No arrow. No. Anyway, they could probably. Oh, the red thing is the cursor. I didn't know that. Oh, I thought. Oh no, there's a big burned spot on the. Oh, here we go. Here we go. Yeah. Oh, okay. Oh well. Anyway, so anyway, here's another one. But yeah, a lot of times I see you know, several streaks going different directions, and I have to kind of figure out, you know, which one's what I'm looking at. Sure.
In any of the gathering of images and calculating PLE data, have you ever dealt with probability of collisions with satellites could lead to debris fields?
No. That would probably require a lot more computer power and brain power than I have. You know what I mean? So, no, there are people that do that. I know the Space Force does a like a hourly prediction or something like that, and they predict sometimes, you know, many, I don't know how many, but potential collisions, you know. But I mean, most of the time, most of the space, you know, the collision probability is really low, you know, and then not like like ISS, you can't spend all day long burning the jets, you know, to avoid all the collisions. You'd run out of fuel. So anyway, okay. Well, anyway, so that's if anybody's interested in how to do this or wants to come by and take a look and see how we do it sometime, let me know. You know, I'm just right down the road here. So thanks a lot.
All right, Charles, thank you very much. Oops. Okay, so Rick, we got some Sky and Telescope magazines.
And there's 5 right up there when you walked in. So go ahead and pick them up.
Excellent. Thank you for bringing those free Sky and Telescope magazines. The meeting after the meeting. So when we get done here, we will zip up to Mod Pizza, the one in front of HEB at Clear Lake City Boulevard in El Dorado. Everyone's welcome to join us, and we'll continue talking about satellites in American town. Okay, so for our break slide, just wanted to mention this is a image or a video from Jonathan Kistner. He's a physics teacher at CISD. He also is a contributing editor for Sky and Telescope. He was one of our speakers a few months ago, the guy who did the 3D printed telescopes. Anyway, he contributed that that video of the sun. And thank you, Jonathan, for contributing that. So we'll take a short 10-minute break, and then we'll get back together and do the second half of our meeting. No, I don't. Sorry. Okay, 10-minute break. 3:30. Okay.
Oh, yeah, of course. Like I have. So you can come on. Well,
Yeah, this one I would like to get back to which I can see. No, I'm not saying I'm and the sunlight. Oh, yeah. So I can be straight, it's better. I know, I can't wait until actually when I'm retired.
So you're getting. There's a translation. The other one, the other on.
Yeah. Yes.
All righty. We're gonna try to start the second half of our meeting. Hey! That was Trevor, not me. This is me. We're trying to start the second half of our meeting. See? Here it is, my Rungu. You guys can talk out in the hallway if you want to. We don't want to keep you from talking. Just don't interrupt our meeting. Thank you. All righty. That's my favorite part of the whole meeting. Okay, Astronomy Day 2025. Okay, so this is important. So Astronomy Day this year, 2025, is going to be on September 27th at the Insperity Observatory. So, you know, they have in the past, they had them out at the Georgia Observatory, but now it's going to be at the Insperity Observatory. But it's going to be pretty cool. It's going to go from the middle of the afternoon into the evening. They're going to have solar observing, outdoor talks, tours of the observatory, tours of the astronomy and art. Not sure what that is. Indoor talks, youth activities, information tables, deep space observing, green laser, constellation tours. So it's going to be a lot of fun. And there's been a couple emails that have gone out about this. And I think 3 that I've seen so far. And there's a list of things that they're looking for people to volunteer to do at Astronomy Day. So here's the list. And if you want to volunteer, what you do is contact Aaron Clevenson at this email address. Now, this is actually going to be a part of the Houston Science Festival, September 27th through October 4th. So they could have a pretty good turnout. Also, if you're familiar with the Insperity Observatory, it's actually on the campus with an elementary school. So there's a lot of families and kids and stuff that are there. And they were last time we did this. If you don't want to, what? I'm sorry, what, David?
Sorry, just go back.
One before this. Yes, go ahead. That's our flyer for the event. Yes. September 27th. It's in Humble, if you don't know where it is, Humble. Insperity Observatory. I see one phone still up. Yes, thank you, David. Yeah, astronomyday.net. Did you get your picture? Okay. Okay, she's looking down. All right. So if you can volunteer, please contact Aaron Clevenson. That'd be great if you can come. And if you don't want to volunteer, but you just want to come, you can actually go to astronomyday.net and sign up. And what they're doing is they're just trying to get a head count of how many people are coming. They don't know if there's going to be 10 people there, there's going to be 10,000. So they're trying to get people to, you know, go there and say that you're coming or not. And this is kind of a aerial view of it. The observatory is here, the elementary school is here. They're going to have deck scopes out here, green laser tours over here. Lots of parking, but like I said, I went to one of these a few years ago and it was actually really fun. So I hope you guys can participate. All right. So, yeah, the Insperity Observatory has a public night every month. Yeah, I think at least once a month they have a public night and you can go up there. But Stan, get a look at their equipment. Yeah. No kidding. I mean, this is like, yes. Yeah, CDK. Okay. Isn't it? They're tall. Everybody in Humble's tall. Don't you know that?
We usually have, they can both move in different orientations. We don't have them all look at the same area of the sky. And then we
Right.
do a clear operation, make sure the scopes are pointed differently so they don't collide with each other. But they're nicely evenly spaced, so we don't have that particular issue. And then we have I think a 130 Takahashi there on the far left.
Yeah, if you haven't been up there, you want to go. It's actually a really great piece of work, what they've been able to accomplish. And the Insperity guys that paid for this whole thing, they did this right. I mean, it's not a sloppy deal. They did a good job with it. Any other questions about this? Going to be a good event. I hope you guys can either volunteer or just come and participate. Okay, DIY astronomy, increasing the sensitivity of a radio telescope. Okay, all right. See, I just love it. Every time I say this, no, I just want to see the reaction every time I bring this up, because some people. Oh, thank you for that. But some people just look like this is the best thing they ever heard, and then some people look like they want to hurt me after the meeting. So I just like to look around and see who's going to get me afterwards. Okay, so increasing the sensitivity of a radio telescope. The unit of flux density for radio astronomy is the Jansky. Okay, so 1 Jansky equals 10 to the minus 26 watts, which is power, per meter squared and per hertz. And so we're going to be concentrating on this per meter square and per hertz is our way of increasing the sensitivity of a radio telescope. So if I'm doing optical astronomy, visual astronomy, if I want to see dim objects, what do? I get a big telescope, right? Little telescope, big telescope. Big telescope, more area, more collecting area. That addresses our per meter squared part of our units. Same for a radio telescope. Can you believe this is actually a radio telescope that looks like that? It's somebody's hand. So bigger area, more collecting area, more sensitivity. The other thing I can do is we can actually increase our bandwidth, and that addresses our per hertz part of our units. So if I'm doing optical astronomy or visual astronomy, if I use a narrow band filter on a continuous object, less light through. If I use a broad band filter, then more light through, right? More sensitivity. So the same thing with a radio telescope. So what we'd like to do is we want to explore how can I increase the bandwidth on a radio telescope to increase my sensitivity. So here's a general architecture of a amateur radio telescope. There's a parabolic reflector over here, which gathers and focuses electromagnetic, radiation into our feed antenna, which converts this to a electric current. And our electric current is going to feed a low noise amplifier combined with a bandpass filter. And the bandwidth of this device is 65 megahertz. So that's important for the rest of the presentation, 65 megahertz. The output of this then goes to my receiver. And so far, what we've been using is a software-defined radio for our receiver. And a software-defined radio is a gadget you can plug into your computer and listen to radio stations on your computer. But you can also use it to hook up to your radio telescope and do, astronomical observations with it. But we can look at this. Okay, my software-defined radio's bandwidth is 4.8 megahertz. So we're bandwidth limited by the software-defined radio, 4.8 megahertz versus 65 megahertz. That's where my limitation is. Now, what if there was some way that we could get the full bandwidth of the low noise amplifier? See? Then you could increase the sensitivity of your radio telescope, right? So one way you could do this is you can use this gadget, which is called a power detector. So a power detector takes in RF or radio frequency energy on one side and puts out a quasi DC level signal on the output, which tells you how much RF power is coming into this device. And once you've got that, you can take that and run that to an analog digital converter. And so for our experiment, we'll use an Arduino Uno R4 Wi-Fi. It has a 14-bit analog digital converter, which is pretty good because if you've been following the Arduino world, the old ones used to have 10 bits. So now they're up to 14 bits, so getting better. It also has Wi-Fi, so that means you can sit in your nice air-conditioned house while your radio telescope's outside in the heat and humidity, and you don't have to sit out there with it. You can just, get your signal off your Wi-Fi. And it has an onboard op amp. So an op amp is this device that you can add resistors and capacitors to and make amplifiers and filters. And the nice thing about it being on board, it means you don't have to have a separate circuit. It's already built into the Arduino. So this is the newest of the Arduino Unos, and it's got a lot of nice features for this project. So now here we go. Here's our new architecture. Everything's the same, except now I have this Wi-Fi transmitting 65 megahertz bandwidth receiver. So now I can get the full bandwidth of our low noise amplifier plus bandpass filter over here. Full bandwidth. This is one way to do it. So let's do a test with something bright to see if we gained anything. So we're going to point this to the sun, brightest thing in the sky, right? And we're going to do the sun crossings. So a sun crossing is where you point your radio telescope at one spot in the sky, one fixed point in spot in the sky. And then when the sun goes by it, you get a signal from when the sun passes over your radio telescope like that, see? All right, so when we use a software-defined radio for our receiver, we get a signal of 6.3 dB. But when we use our new receiver with our power detector, we got 9.19 dB, right? So success, it worked, right? We got bigger signal with our wider bandwidth. So we're real happy about that for about 2 seconds, okay? And then we start thinking, okay, wait a minute, that's pretty cool, but is that what we would expect, all right? And is there some way we can quantitate our results? Is there some way we can calculate the difference between these two different measurements? So one thing we could think about is the sun putting out different amounts of energy on from one day to another. And thanks to our friend Forrest, there's Forrest. Okay, there's Forrest. We are now aware of the solar flux unit. So solar flux unit has to do with the sun putting out different amounts of power from one day to another at different frequencies. Okay, and it's nice, you could actually look this up on a NOAA webpage. You can find out what the solar flux units are the frequencies you're interested in on the days you're observing. So it turns out on the day that we got the 6.3 dB, the solar flux unit was 135 at 1415 megahertz. On the day that we got the 9.19 dB, it was 97 SFU. So they're not the same. And interestingly enough, if you look at from an active sun to a quiet sun, it can be 1,000 times different from one time to another, depending on how active the sun is. That's a lot. You know, think about if we went outside and if it was the same in visible light and heat, if it was 1,000 times hotter, 1,000 times colder from one day to another, that would be bad news, right? But in the radio frequencies, there's large variations in what the sun puts out from one time to another. Anyway, that's a sideline. It doesn't have anything to do with what we're talking about. So I said it before and I'll say it again. Math is fun, right? It is. So we can take our solar flux units, convert them to Janskys. There's 10,000 Janskys in one solar flux unit, and put in the dB formula, you get 1.44 dB. So that's something, right? Now, so what we're trying to do is try to calculate the difference between this number and this number on these different days. But my solar flux was larger on the day we got 6.3 dB. So I need to take the 1.44 dB off of this. I get 4.86 dB. And that's not real good because we're actually trying to get these numbers to equal each other, but instead they're getting farther away. So the solar flux didn't help me, even though Forrest told us about SFUs, that was a good idea, but that didn't fix our problem. But you remember, the objective of this presentation is to talk about increasing our sensitivity by increasing our bandwidth, right? So we have to put in our different bandwidths to see how much that affected our results. So in the radio astronomy world, there are lots of equations that use this scaling factor, the square root of bandwidth times the number of samples times the sampling time, to scale up and down temperatures and powers. So if I take these and I put these in the dB formula, I've got my new 65 megahertz. I used to have 4.8 megahertz. I know the number of samples for each one of these tests that we just did. Now, what we don't know is we actually don't know the sampling time of the software-defined radio or the Arduino. So we're just going to guess they're about the same. Okay, it's just a guess. And we get 4.48 dB. So we start out with our original number. We take off the effects of the sun changing from day to day. And then we add in the gain from our bandwidth, and we get 9.34 dB. And that is close enough. So we're going to declare victory and say, yay, we can calculate the difference between these two different measurements. All right. Now, you guys might be thinking, okay, wait a minute. You were telling me we're trying to increase the sensitivity of our radio telescope, but you pointed at the sun, the brightest thing in the sky. Like, how hard can that be, right? You pointed at the brightest thing. We're talking about increasing the sensitivity of our telescope. Big deal. Okay, so that's a good point. So what we'll do is we'll point at something that's a lot dimmer than the sun. We'll do supernova remnant Cassiopeia A. Okay, so Cassiopeia A, or Cass A, is 2,400 Janskys. And that's way smaller than what our sun measurements were, right? Way down there from these gigantic sun measurements. So here's Cass A with the software-defined radio. And here's Cas A, it's in here, see there. But if you look at this and then you look at how big the noise floor is, the noise floor is almost as big as this actual signal itself, right? I mean, it's cool that we can detect it, but you know, it's not really too big. On the other hand, if I use our power detector receiver, here's Cas A. It's real big, nice big signal, and our noise floor is actually down here. But this plot then reveals what the problem is with using wideband receivers. Now I've got all kinds of man-made noise, probably from Charles's satellites, I'm thinking, interfering with all my measurements.
Sorry.
There are just too many satellites out there. Anyway, so this is over 19 hours, over 6 hours, but the Cas A signal itself is much bigger than the actual noise floor, which is this. But now you've got to contend with all these man-made things, which are riding on top of our astronomical observations. So this is Cas A. This is actually the Milky Way here. And I don't know what some of this other stuff is. Okay, and then how about the moon with a satellite TV dish antenna? You guys remember a couple months ago, I told you how to measure the temperature of the moon with a satellite TV dish antenna because I was trying to satisfy Trevor and Phil, who didn't even come tonight. But this is our plot with the software-defined radio. Here it is with the power detector. Now the power detector signal is bigger. It's 0.172 dB versus this one is 0.063 dB. So it is a bigger signal. So yeah, it did work, but the man-made noise is huge on this compared to the other one. So let's do a lot of stuff. Now, one more thing. Okay, so I told you can increase the sensitivity of your radio telescope by getting a bigger telescope, right? Area, meter squared, or you can get more sensitivity by increasing your bandwidth. So the question is, how much bigger would we have had to make our radio telescope in size to get the same gain that we did by increasing our bandwidth, right? So there's a nice formula here called the sensitivity formula. And what you're supposed to get out of this, if you look at the area, this is our area, and this is the square root of our bandwidth. In this formula, either one of these scales this thing up and down the same. You know, mathematically, it doesn't matter one or the other, scales up and down. So you can increase or decrease either one of these, and they get the same effect. So if I take our two bandwidths again, 65 megahertz versus 4.8 megahertz, take the ratio of those two, take square root, I get this number. That's the same as if I had increased my area by that same number. Has the same effect. If I know my new area, then I can actually calculate what the diameter of the radio telescope would have had to have been. So our original diameter was 2.1 meters or 7 feet. But to get the same increase in sensitivity that we did by increasing our bandwidth, we would have to go up to 4.028 meter diameter or 13 feet, 2.4 inches, which is almost twice as big as my current radio telescope. So that's what we gain by increasing our bandwidth. So in conclusion, yes, we can increase the sensitivity by increasing our bandwidth, but increasing the bandwidth adds unwanted noise. So that's the conclusion, but I'm not done yet. So just for completeness, if anybody wants to do the same experiment, here's a schematic of the power detector receiver configuration. That's the schematic. And that will be posted on my webpage along with all my other adventures if you guys want to do that yourself. All right. Any questions? Dan.
Talk to your neighbors. Back.
Ooh,
Interferometer.
I want to do that so bad. I do. You guys just tell me which one of your yards I can put one in. David. Say it one more time. No, you'd be surprised how heavy that thing is. I mean, I had a really hard time getting that put together. I don't think I can I was originally going to make a 10-foot one. What? Yeah, it's really heavy. I was originally going to make a 10-foot one. That was 7 foot. I'm really glad I didn't make the 10-foot one. I wouldn't have been able to deal with it. Yeah. So,
Now, you could have like a mesh, make it lighter.
it is a mesh antenna.
So you get like metal built in like a fiberglass substrate for like shape.
No, what it is, Charles. It's hardware cloth. You know what hardware cloth is like?
So
It's like chicken wire, but it's actually a quarter of an inch square. You buy it at Lowe's or someplace. Yeah, it's hardware cloth, so it is a mesh. And believe it or not, when Hurricane Beryl came through a year ago, okay, we had trees busted all over the place in our yard. Things were everywhere, and the radio telescope was perfect. It didn't even bother at all. Yeah, it snapped. We had trees this big around that got snapped in half, and the radio telescope's just fine. So the wind blows right through it. What was your point?
Oh, no, so a larger antenna would be lighter. I didn't know if it like sort of a fiberglass thing with built-in metal to actual to reflect it or whatever, or was it just metal mesh?
It is a mesh. Yeah. And it'll work up to a certain frequency, but higher frequencies it won't work.
Right, exactly.
Yeah.
You need a tighter mesh or higher frequency. So it's sort of weight.
It's about as light as I could make it, but it's still really heavy. I'd love to make a bigger one, but maybe I will. Who knows? Trevor?
Is there a different style?
Like what?
Style of antenna,
Like what?
as opposed to a dish and something different configuration.
I don't know what it would be, but that's a good idea. I don't know. Any other questions?
They're sticking poles in the ground everywhere on one of them, I saw.
Well, that is a thought. You could actually, you could stick a bunch of pole. Well, then you couldn't. How would you point it anywhere?
It's the up.
That would be kind of fun though. You could actually put a whole bunch of poles and make a parabola, make a gigantic dish, but only be pointing straight up. You can still do the Milky Way with that. That'd be cool. Maybe I'll do that and kill all my grass. Rick. Yeah. Oh, how I expanded it? That's my bigger one. That's my bigger one. Everyone's saying make it bigger. There it is. Oh, thank you. I already made it bigger. That's right. I made it bigger. This was my illustration of making it bigger. So, any other comments before you? Oh, yes, Forrest. What's that? Oh, the hole in the ground. Oh, he's absolutely right. That's absolutely right. Our neighbors dug their own swimming pool. I could go over there and put one in their yard. That's a good idea. Actually, that's how they do it. You're right. They move the feed antenna back and forth to point it. You're making me think, who needs grass? Yeah. Use what's left of it.
To make smaller dish, like a mini interferometer thing in your backyard.
Yeah. Okay. Yeah. I actually have the parts to put together an interferometer, and over time I'm going to do that. It's actually surprisingly easy to make an interferometer. Yeah.
Probably software radio that write it all in the same.
Yeah. Actually, there's the little circuit board you can buy. And what you do is you take both telescopes in, and it actually puts the phase difference comes out. It's really great that exists. Yeah. That's cool. Okay. Any others before we move on? Okay. All right. Good enough. So next up we have Al's going to tell us what's up in the sky and what's going on in astronomy today.
Well, what I want to know is when are we going to have a radio telescope workshop where we all build a radio telescope? That's what we need, right?
Yeah.
And then Doug will have the opportunity to link us all together at one time with some software. So we're in August. So finally, we have some big meteor showers. So this is the big Perseid meteor shower. I'm hoping one day I see a great meteor shower. I've been out for so many meteor showers and I've never seen a great one. But I think one of the things, I think the moon is probably either setting or rising still early in the evening. But One thing I know is you got to go out later. Most people go out about 10-ish, 11-ish, and I think most of the meteor showers get better kind of midnight, 1 o'clock kind of. And that's what makes them tough because most of us have kids and other things going on. But look forward to that. That's just in another week or so. Very first object, M70 in Sagittarius. So we're still hanging around Sagittarius. And I try to look up some factoids on these different objects. And what I know about this one is there's several things in this talk I didn't know anything about. And this one is that some globular clusters have gone through a core collapse. So that means the amount of density or the amount of mass has gotten so great that it's wanted to shrink. And this has undergone one of those. What you can do with that, I do not know, but it's very interesting. I think we look at some of the globulars and they're kind of spread out and wide. You know, they're not so clumpy. So next object, M54 in Sagittarius also. So I did not know this. So you, in the right picture, you might just barely be able to see this down below this wording. This is a satellite. Sorry. This is a dwarf elliptical galaxy, and it's a satellite, so it's actually near us. And I didn't know this before. I don't think I've ever looked at this galaxy, but that's pretty cool. I like this really wide picture of the Milky Way here. Next object, M20. I've looked at this most of my life. Whenever I would camping, I would pull out the binoculars, and between the Lagoon Nebula and the Trifid, I would look at them all the time. I never knew why it was a Trifid. Does anybody know why? Three things. So red is ionized hydrogen gas and reflection nebula. Blue is reflected dust particles, and then the dark part of it, which I never really thought about the dark part myself, but is dust lane. So that's pretty cool. Just a wonderful object. I can't remember what filters. I don't think it's an O3. It's probably a deep sky, helps to make it look a little bit better. So first telescope object. Now I named this after what Stellarium called it, the Southern Ring Nebula. And I've looked at the Southern Ring Nebula, and that is not this one. Stellarium has an error in it. It's called something else. It doesn't have an actual name. So 6563. And what's unique about it is its oval nature. There are several planetaries that are ring like that. And so that's kind of a different look. Bipolar planetary nebula in Sagittarius. I've not looked at this one. I think this is a hard to find object or hard to see object, but it obviously has a pretty odd looking shape, and that's what makes planetaries neat, is seeing the structure of the planetaries. So if you have a decent sized telescope that you can kind of zoom in on this one's small. Next one is, I thought I did this before, but this is really cool. It's called Robin's Egg planetary nebula. I like planetary nebula, so I pulled out several for this talk. I like this. What?
Are these both the same?
It's supposed to be. You know, I search this stuff online and I can only spend so much time on it. I try to show you a picture, especially for these smaller objects, what it would look like in kind of a not quite so zoomed in picture, because this picture on the right is probably a Hubble picture, and we're never going to see a Hubble picture. So I like to try to get like something representative of what you'll actually see. Telescope objects, Capricornus, Behemoth Galaxy. Never seen this one, but what's really cool is it has this other little galaxy in it right there. So I think it's a foreground background set of galaxies. It's not an interacting galaxy, but it also is a barred galaxy. So I don't know how many there are, but we have so few of decent sized barred galaxies. This is another cool one we should all go look at. And then this is an odd one. Never looked at this one. I think this is a little bit faint in most telescopes because it's kind of spread out and what do you call it? Diffuse. but Barnard's Galaxy, and it's nearby, but it's not really. It's I'm learning so much, but there's galaxies in our local group, which is in a sort of a dispersed area that's not. It's like the cell of a body. It has a lot of empty space in the center and then a whole bunch of stuff on the outside edge. And we're in this local group where we have a whole bunch of area like toward the outside, and there's galaxies dispersed around here. And this is close, but it's not in that local group. I don't know what that really matters, but okay, what's happening? Now, I didn't make a lot out of this picture. I wished I did. I didn't have time to really study it a lot, but the very first one here is the James Webb uncovers hidden black holes devouring stars in dusty lanes. So, the James Webb is really looking at obscure small galaxies, like early forms of galaxies. And one of the other things they're looking at is black hole discoveries, protoplanets. That's a lot of the three core things that the James Webb right now is being used for. And what they've been doing is looking at these tidal disruptions. So when a star comes close to the black hole, it's going to make some kind of a thing. And what it does is it probably disrupts the star, and some of it sort of shoots out and some of it gets absorbed. And in that, there are these tidal disruptions, and they look like jets and stuff. And the next picture will show a little bit more about exactly what they did. So the picture on the left is the burst image, like when the star gets gobbled. The right image is a image that was done several years before. I think this is a 2015 on the left, and then this is 2011 on the right. And what they did is they did like a subtractive process to get the lower picture on the left to kind of illuminate those jets or that accretion process. I mean, they're just figuring out all sorts of tricks and ways to try to get data and kind of visualize what's going on. And then, of course, this is the galaxy on the right. So that is so bizarre that in the infrared, we're getting these kind of black and white pictures. And then the galaxy really looks like this. I think the James Webb is zoomed in on that core. So the right picture is probably like a Hubble picture or something. But these pictures are really the core part. Probably it's probably zoomed in more than the picture looks right now. Okay, next object. We only have 3 tonight. The next one, a swirling nebula of 2 dying stars, revealed in spectacular detail in new James Webb image. I don't know. It's just really cool. So they're really focusing on these Wolf-Rayet stars, and these are these very big massive stars, and I think they're very intrigued by the different processes and what happens as these big stars die. Some turn into supernova that eject, and some turn into blue stragglers, and some are these Wolf-Rayet stars. And so the left is a kind of a computer generated, like what has happened to make the image on the right. And so they're looking at these jets and kind of streaming out, and as the star revolves, then it wraps around and then creates this interesting pattern. It's just like planetary nebulas. We get so many different shapes, ovals, circles, and we try to figure out exactly how they occurred, and that's what makes it interesting, I guess, to study. The last one, did anybody know Betelgeuse has a star near it? Another star near it? Well, they've been trying to confirm this for years, and they realized there has been this kind of a period of variableness, and there's a 400 one, and then one that's kind of a 6-year period. But what really got them started is in 2019 and 2020, they saw a real decrease, completely different than anything they've seen over the years. And they called it the Great Dimming. And that's why they wanted to study it, because like, well, so what's going on? Maybe this will finally confirm what we've suspected, is that it's a binary. And they use this technique called speckle imaging, and they use these short exposures, and that way they can compare them and get a little bit more distinction and separation in items that are really close together that they never had before. So it just goes to show you that they just continue to just figure out new ideas and techniques, and so many people are involved in astronomy. It's just incredible what kind of data and stuff is coming out today. Thank you.
David, Star Party News.
All right, this will be interesting. All right. Friday, a week ago today, we had a Hack Winery event. I'm going to talk about that when I get there. Got pictures and a few stories. All right, September 19th through 20th is going to be Okie-Tech. September 20th, as Doug mentioned earlier, is Astronomy Day at the Insperity Observatory. And if you haven't gone to that observatory, it's worth making the trip. It's in a very, very impressive place. September 28th, a lot of this is on the website. There's again another one, but this one's on a Sunday instead of a Friday. October 16th through 19th, Club's trip to Fort McCavett. I've already put the primer up on the website. There are reasons for that already. El Dorado, 20th through 25th. We can be allowed to daisy chain these for those who want to do it. November 1st, Sun and Moon Night at the George also happens to be recently added as of yesterday. November 1st, we've got another event at the Evelyn Meadow Library from 7 to 9. It's going to be a gorgeous first quarter moon, which is why this was there. I have to decide which one I'm going to. November 15th, Saturday, Magnolia Creek Golf Course is there, and dates are still currently under discussion with Armand Bayou Nature Center. All right, sliding into 2026, March 23rd through 19th through 23rd would have been our normal trip to the fort. But a couple of people, namely in Austin and the San Antonio clubs, kind of, hey, why don't we try doing the Messier Marathon? For those that don't know, this is looking up all 110 objects in one night. Connie and I were there at the fort when it happened organically. I don't particularly care for that word. It just kind of happened spontaneously of the people who were attending. And it was all done visually, not photographically. So it'd be like, Connie's got a scope and she says, okay, I got this object in, and everybody comes scattering over like mice and looks at the object. And then Trevor says, I got this object in this scope, and everybody scurries over and we all look at it. And we do it as a big team effort, but it takes you all night. And you look at all 110 Messiers. It's gotten quite a bit of chatter and snowball, and it's snowballed. Right now, there are 14 clubs that have been contacted. 6 have been confirmed. I'll be talking about this as we go on the net, and maybe a little bit more next month. I've had to get information from the fort. I've had a deluge of emails from the fort, from the people coordinating this and the fort. Right now, the fort is willing to accept 100, cap it at 100 people, 25 to 30 in the barracks. Everybody else is in tents. How they divide the barracks, male, female, mixed, is up to them. There will be power on the parade grounds. The fire station has opened up 14 RV slots, 30 amp only service. Truthfully, they're thinking it's going to be 30 to 35 dedicated people. We'll see how it all plays out. I'm dealing right now with people who've never been to the fort. Some people trying to make demands saying, well, the fort needs to move its star party. That ain't happening. Fort sets the rules. The star party is going to be on Saturday night. End of story. If you have to run the marathon at the same time as the star party, that's going to have to happen that way. However, some of you have looked on getting the emails. There has been a little bit of back chatter, and as of 3 o'clock this afternoon, the fort has agreed April 9th through April 12th, the weekend before, we can come out just JSCAS. So there'll be the Messier Marathon on March 19th through 23rd, but in April 9th through April 12th, just JSCAS can come back out. We've already got that approved. The only rub is it's going to be a waning moon, and the moon technically is slated to rise the earliest on Thursday at 2 in the morning. It'll take another 35 before it clears the barracks, but if the moon comes up in the east and you're doing imaging and off to the west, you're still going to have plenty of time. And then when I've talked about the moon's going to rise about 40 minutes later each night. So come Saturday, the moon's not going to be up until almost 3:15 in the morning. That's the only weekend it works, and the fort has agreed to that. So right now, that's kind of the plan. Any immediate questions? I don't know how this is all going to play out as far as this Messier Marathon, but we'll see. October 8th through 12th, by the way, the club's October trip to Fort McCavitt. I did get a very interesting note from Kevin. Just dropped his last name. Kevin at the fort. Apparently, the public night is now a very popular thing out there. So they definitely want us. They definitely want us coming out. So I consider that a good thing. All right. August 1st, Hack Winery. Big thanks to Bob and Leslie Eaton, Reed, Chris Randall, Stan and Florine, Florian Lamb, Rick and Rick Slater, and I forgot myself and Connie. But there we are. We had about 100 to 150 in attendance. I would have bet all of you tonight's pizza that on Friday afternoon at about 2 o'clock, this is going to be a cancel. But Astrophyric actually told me the truth, and the sky started to clear up at 5. It was soft as all get out. Right around when the sun decided to finally drop below the horizon, it really started crisping up, and the crowds came out too. And I was showing people pretty decent resolution of the moon. Chris, I think, did 57. I think dug up Mars. Here's Stan and Rick. Reed setting up his wonderful sea star. Thank you, Reed, for the picture. And I took the liberty, Reed, of mapping the Apollo sites for you. Connie talking to somebody, those ladies over here. She looked a couple of people came back quite a number of times throughout the night. Stan wonderfully brought his solar scope, which was a big crowd pleaser. As I said, started out awful, but sharpened up nicely after sunset. And then I was kind of in an off dark mood when I found this cartoon, but I thought it was kind of cute. Shoot for the moon, even if you miss, you'll be amongst the stars. Suffocating. Okay. Do we have time? You want me to go ahead and punch it?
Yeah. Just go ahead and punch the button.
All right. Fort McCavitt Permer, for those of you that haven't gone, I encourage you to go at least once while you're in the club. Where is it? Yep. Here's Houston, San Antonio. Keep heading out I-10, San Antonio, Kerrville, Junction. Just past Junction, you hit road 1674, head north, almost the equivalent of a marathon. And you come up here to this T intersection of railroad and what's called Tadpole Road. You make the right turn at the T, come around, and then here's the fort. This is an old picture that I've been using. Here is a brand new picture, aerial view of the fort. Since moving under Texas Historical Commission, they've actually done quite a number of improvements for the fort, including the actual paths on the parade grounds. Many of you remember from times past, we would be able to sleep in the officers' quarters. They have apparently updated those to period furniture and everything. There's no sleeping in those quarters. Only in the barracks. Tents are back here in back of the ruins. We can no longer camp in the ruins. RVs are not allowed, but I'll talk about that shortly. Tents back here, as I said. Here's scopes open, something going on. I can't guarantee those are scopes, but I usually on the northeast corners where we park everything. I've got confirmation today that they still have the stuff that the club donated to them as far as powers and reels and extension cords. They will only be supplying power to the northeast and maybe a little bit of the northwest corner. People in San Antonio were asking, well, can we have stuff down here? No, if these are people that have never been to the fort, and I'm dealing with those questions. If you've been to the fort, you know this is very rocky, rough area. It's a great place to twist an ankle. It's back over here where the old armory used to be, so they didn't build it up or have it set up very well. Fire station road can move on. So let's talk about the RVs. Limited total number of 14 slots. This is new and welcome. 30 amp service only, no 50 amp. You have to decide which leg of your RV you want to power. Not aware of any restriction as of yet. Single dump station at the firehouse. This is a business with the fire station, so it's $40 a night. Sarah Fusig at the fire department. There's her phone number. They have to be booked directly with her. I think I've already put that out on the list, but I will again. This is in the primer. This primer is up as a PDF on the website right now. It was up as of Tuesday. The path between the fort and the station is for walking for cars for people without having to use the main road. But do recommend flashlights, red flashlights. Doug. There was a fence, but I'm understanding there now is free passage between the fire station and the fort. I don't know. That's a question I don't know. There is a gate, but it's so people can get from the fire station to the parade grounds without having to use the main road. Here's a dial-in of the fire station. Each of these little black dots are RV pedestals. So ideally, that's where your water and power would be. Some of these spots can look kind of small. As I said, I don't know the RV restrictions. Moving on to the fun stuff, the parade grounds. Some of you may have seen some of these before. Views from the barracks where people can be, and the northeast side where we will have scopes. These are definitely some older pictures. Scopes, parade grounds, the hanging tree, which I understand is no longer there. Yeah. Connie and John with that LX55 scope that we still have. And there are a couple of things back here. That may even be our RV, all right, Connie? Not anymore, and I can't park back there anymore. But as I said, they will supply power to the northeast corner of the parade grounds. Food, work with your friends, traditional potluck Friday night as it goes for the event. Check for a burn ban. If you see Fred Miller, stay close. He cooks very well. If he's not there, then you got to figure it out. Gather for a mandatory picture if you can. What to bring. Double check the weather, whatever you prefer. In March, we've had weather in the 70s and 80s, all the way down to 21 degrees in March of 03. Check weather at least 10 days prior. Pack accordingly. October can be nippy as well. Bring a sleeping bag and appropriate clothes. If it's going to be in the 30s and 40s, you're not going to use a fleece sleeping bag. That's not going to work. Bring a hunter's suit. If you've got one, mitts and a hat. Scout motto, be prepared. Come with Google Maps and how to get to Menard and Junction. Cell service may be limited, so planning ahead definitely helps. Plan all your meals. Friday night, bring something to put on the grill and a side dish. It's a potluck. Plan for alternatives. If there's a burn ban, have a propane stove or electric griddle. If you arrive early enough on Thursday, a group traditionally has gone to Menard for dinners. But be prepared. Menard is a small town with a small town attitude. Some restaurants are cash only. Connie and I, and John, I think, was with us. We had to go to Menard because we were missing something for our propane setup. We go to the hardware store, closed. Grandpa decided to take a nap in the middle of the afternoon. Well, fortunately, granddaughter was there and let us in and let us buy that one little thing, but let us out. But otherwise, the store was closed. Small town. You want more, head to Junction. But Junction is, of course, back down the road, 60 miles away. Try to be as close to 100% self-sufficient as possible. Ice for ice coolers. You may want to get one of those fancy JRTC type coolers. Otherwise, you may need to head in Junction or Menard for ice. Figure out how you want to eat, how you want to work it. It's 2,000 feet mean sea level. It can be quite dry, so you will need chapstick and water, bottled water preferably. Schedule: arrive Thursday, set up dinner. Friday, breakfast and lunch. You're on your own. Friday can be the communal dinner. Saturday, you're completely on your own for meals. There is understanding there is a public star party that night. That's our service to the fort. They're asking the Messier group for possible seminars on Saturday afternoon. Sunday, on your own, your food, you can pack up and leave. I will coordinate with the fort, so those that might want to do El Dorado can stick around till Monday. Anybody wanting to go, holler. It'll be on the list. What you will find at Fort McCavitt: showers, 2 open air showers. Only buzzards and airplanes with really good cameras can see you. Connie and I have looked and showered by the light of the Milky Way. We have also seen our own shadow by the light of the Milky Way. That's why it's a Bortle 2 skies. That's why I had to sit there and laugh, but answer the question when somebody said, what are the hotels from the Messier group? What are the hotels in Fort McCavitt? I go, you don't have Bortle 2 skies and a Marriott. Ain't going to happen. Your closest hotel is Menard. I would say motel at that point. Bathrooms, porta potties, nice people, great weather permittings, and a chance to get away from it all. As I understand it, AT&T is still good at the fort. I don't know about Verizon. Last I was there, Verizon goes dead about two miles above I-10. What you won't find at Fort McCavitt, about the only thing you're going to find at Fort McCavitt is the sky. That's why we go. Nearest town is Menard, 23 miles away. Junction's 40. Thought it was 60. I'll double check that. Nearest Walmart, if you're a Walmart addict, is Brady, 60 miles away. San Angelo is a day trip at 80 miles one way. Think about what you find. No, I've already got that one. You get the feeling if you're out there in the middle of nowhere, it's because you're out there for a reason. The skies. So I might most importantly want you to have fun. Any questions? Feel free to post it to the club's email list. You can go directly to me if you want. Doug, anybody who's been to the fort recently can chime in and answer questions. But I do encourage you, if you have not been to the fort, you owe yourself those Bortle 2 skies. Mark. I honestly don't know that, but I wouldn't expect it to be more than a few hundred yards. But on that area, that's another discussion I'm having. They're saying, why can't we set up over here? Well, once you get past the parade grounds, that's nice and level. For water management, everything starts sloping away, particularly where the old armory used to be. I know it's downhill and rocky around that path to get to the fire station. The path on the fire station should be a dirt road. It should be okay, but you want to stay on that. Out of that area between the fire station and the parade grounds, if you're not on that dirt road path, that's ankle twisting territory. And probably animal territory too. I wouldn't want to put any wagers on it, but given the dry area, the elevation, probably diamondback rattlers. Probably not going to find many water snakes over there. So scorpions, yeah. Anything else real quick? Over to you, Doug.
Okay, thank you, David, for coordinating all that. That has been a little more challenging than the normal Fort McCavitt trips. Okay, next month, September 12th, right here, we'll have Charles Armstrong will bring us EVA 23, the story of NASA's most dangerous spacewalk. That'd be good. All righty, get your door prize tickets out, and we'll do a couple door prizes here, and then we'll scoot. What? Oh, okay. All right, first one. 357. Oh, sorry. 367. Are you 357 or 367? Come on down here. See these glasses? They don't always work. I'm telling you. Okay, let's see here. I got some good things. All right, we got a moon map. We have a STS 101 crew pictures. We have a book called The Astronomy Cafe, the best 365 questions and answers from Ask the Astronomer.
Book.
You like the book? It's a good one. All right.
Thanks, sir.
Thank you. All right. All right. Next one. You're not gonna believe this one. Okay. Okay, 375. 375. Is that David? Oh, I got a moon map for you. David's the one that makes the moon map, so I gotta give. Yeah. Okay. Oh my goodness, David. What can I give David? Oh, I know another thing I got for David. What is it? Where is that thing? Oh, I have a meter that worked the last time it was used.
More multimeters than I know what to do with.
No,
That's
you-
why I donated.
You donated this one. That's right. Okay. I got a map of Saturn. I got a map of Jupiter. I got a book called Leadership in Space, which is famous speeches by NASA administrators. I give this one to Randy, I think, before he leaves. Yeah. Or I have STS 101 crew pictures.
I'll take a map of
You want a map of Saturn? Oh,
Saturn is one of Connie's favorites.
excellent. All right, David. Okay. I'm almost out of time here, but I like giving these door prizes away. 383. What? What's your number? I'm not. Oh, is it you, B? Come on, B. Oh, B, I gotta find something. Oh, here. Here. Teach Yourself Electronics, a self-teaching guide.
You don't need to look for it.
What? You really want that?
Yeah.
Yeah, it's actually a really good book. I mean,
Yeah,
because
I
you
know.
do astronomy stuff and you want to learn a little bit like about electronics. This is great. You're right. That's what I would do. All right. Hey, B. Okay. Last one and then we'll skedaddle, I promise. Oh, I haven't brought up my radio astronomy socks yet. Okay, I'll do it this time. Okay. Last one. 385. Is that you? No. 385. Got 385? Okay, then. Trevor really wants a door prize tonight. I got some socks right here. 390. Stan! Come on down. Let's see. What would Stan like? You know what? Moon map? Man, we're doing good on the moon maps. All right.
I do one with an inverted vision.
No, I don't have anything like that. Okay, very good. 4-door prize. That's pretty good. Tell you, David, 1 out of 4. Did you see that? 1 out of 4. I'm telling you, every 1 out of 4 is a moon map. Okay, guys, thank you very much for coming. Hope you guys can all come to Mod Pizza, and thank you for participating. See you later. Yeah. Righty.
Yeah.